In this lesson, we're going to talk about circumference and arc length. So, we have a circle, and we got this thing called the radius that we're familiar with, distance from the center to the outside. If you were wanting to walk around this circle, okay, the question that has been asked for thousands of years is how far would that be? How do we figure out the distance around a circle? And how does that relate to the radius, or more specifically, how does that relate to the diameter? So the diameter is that whole distance across the circle. And how do we figure out the distance all the way around? So that distance around, we have a name for that. Remember what that's called? That is the circumference. So that perimeter, which we call circumference for a circle, is a little challenging to find. Now, for thousands of years, the Egyptians and the Babylonians knew that it was about 3 times farther around a circle than across. So with a little experimenting, we could figure out that it's about 3 times further. However, Archimedes, our friend, the Greek mathematician, explored things a little more mathematically and scientifically. And he said, well, I don't know exactly how far it is around a circle. That's kind of challenging, but I can figure out a perimeter of a nice pentagon. We can use some trigonometry and stuff, and I could figure out a pentagon that goes outside. This is called a circumscribed pentagon. This is an inscribed pentagon. The inscribed pentagon is inside the circle. Circumscribed is outside the circle. Or what if we had a hexagon? That's a little closer because that pentagon's not very close. I could find this perimeter of this hexagon and this perimeter, and the circle's about the average. Or what if I made it an octagon? So if I found the inside octagon perimeter and the outside octagon perimeter, and I could find the circle perimeter or circumference. And Archimedes actually did this for area as well. Maybe even more so. But that kind of gave us the distance around. And what we find out that it's not just 3, that the distance around every circle, the circumference, is always the same ratio. The ratio, the distance of the circumference and the diameter is always the same ratio. And that ratio, we give a name to it. It is pi. Pi is the ratio of the circumference divided by the diameter. Or we can say, if we multiply both sides by d, circumference is pi times diameter. Well, what is this pi? Well, this pi is a number that you guys have seen before. 3.14159 ... It never ends, it never repeats. All right? This is a irrational number, just like the square root of 2. So the circumference of the circle is pi times diameter, or 2 pi r. 2 pi r is just saying 2 times the radius, and 2 times the radius is the diameter, so these are the same thing. All right, so the circumference of a circle, 2 pi r, or pi times diameter. Okay. So we've got this number pi, this irrational number. And just like working with square roots, a lot of times we'll want to leave our answer in terms of pi. So if we want the circumference, and we know we've got a radius of 9, well, we know circumference is 2 pi r, or 2 times the radius times pi, because it's pi times farther around the circle than across. So that gives us a circumference of 2 times pi times 9, which is 18 pi centimeters. So we'll want to leave it that way a whole lot, or often, I should say. If we wanted a approximation, we can go to our calculator. And we'll find out that is approximately 56.55. All right, centimeters. So if we want a rounded answer, or rounded nearest 10th, or in this case 100th, then we want to punch out our calculator. And you have a pi key on your calculator. Don't use 3.14159. That's not even close, I guess, with the 159 is, but don't use 3.14. use the pi key on your calculator if you want a good approximation. So, all right, well, what if we flip this around? We want to find the radius if we know the circumference. So what if we know that we've got a circle and we've got 26? Well, we got 2 pi r is equal to the circumference, and our circumference is 26. Well, we can divide by this number here, 2 pi. 2 pi is a number, it's about 6.28. But divide by that whole thing, 2 pi. Remember, pi is just a number. Just like the square root of 2 is a number, square root of 5 is a number. It's an irrational number. Okay, these cancel. We're left with a radius. And 26 divided by 2, we can deal with that part of it right there. 26 divided by 2 is 13. We can cancel there. And the pi can't do anything. So the exact answer is 13 divided by pi meters. So that's the radius. Now that doesn't mean a lot to us. If you're trying to draw a circle or make a circle that has 13 divided by pi meters radius, well, that's going to be a little tricky. So again, let's go to our calculator. Again, don't use the 3.14 approximation. Use a pi key. And we got about 4.14. Okay, so that's the idea. So that might be stuff that you're fairly familiar with from past classes. But now let's look at partial circles. Okay, what if we just have partial circle? Okay, well, let's start off looking at the entire circle. Here we have a circle in the coordinate plane. The radius is, it looks like 4. So if our radius is 4, we want to find the length of the red arc, in this case, the whole circle. All right, so, well, we know our circumference is pi times 4. I'm sorry, 2 pi r, because it's the radius. So we got 8 pi is the length of that. Well, what if we've got the same circle, notice it's the same circle, but we just want this red arc. Remember, an arc is a part of a circle. So we just want to find this red arc CB. Okay, how long is that arc? Well, it's a quarter of the circle. Well, how do we find 1/4 of the circle? Well, we can find 1/4 of anything by just multiplying, right? So 1/4 of 8 pi, well, 8 divided by 4 is 2 pi. So this is 2 pi because it's only 1/4 of the circle. That makes sense. Okay, what if we have 1/3 of a pi? Now, a different circle here, okay? So let's think how we might get this here. So what if we have this whole circle? Notice this has a circumference of 5. So how far is it all the way around the whole circle? Well, the whole circle is 10 pi, right? And we have how much of that? Well, just 1/3 of it. Okay, so we have 1/3 times that. We find a fraction of something by multiplying. You want to find 1/3 of something? Just multiply it by 1/3. So this is 10/3 pi. Or if you want, let's put that over 1. We can have 10 pi over 3. What in the world is 10 pi over 3, you might say? Well, we don't need a calculator to know that this is pretty close to 10, because pi is 3.14. So 10 times 3-ish is a little over 30. Divided by 3 is going to be about 10. All right, so this number as a decimal is close to 10. Well, what if we have even a weirder, I don't know if that's a word. Okay, well, it is now. What if we have another arc here? This is 5/8 of a circle. Okay, so, well, can we do the same thing? Well, what's the circumference? The circumference, this is a radius of 3. So we have 2 times pi times 3, which is obviously 6 pi. And we said 5/8 of the circle. So 5/8 times whatever that is. Well, 5/8 of this is 5/8 times 6 pi. I'll show you 2 ways to simplify this, okay? 1, we can just plain multiply, and this is 5 times 6 is 30 pi over 8. And 2 goes into both of those, 15 pi over 4. 15 fourths pi. All right. We could also do this. These are all equal that we just did. We could also do this little cross canceling, something you may have seen in the past. Notice how we divided a 2 out here. We could say, hey, there's a 2 in here and there's a 2 in there. I could divide that by 2 on top and divide the bottom by 2. And we could say 5 times 3 pi is 15 pi. And then 4 times 1 is 4. Same answer, of course. This is called cross-canceling. So if you can divide top and bottom by the same thing, you go for it. So anyways, so we can find parts of a circle now by just multiplying the fraction that we have by the whole circle. So if we want to find the length of part of a circle, we need to know what fraction this is. So if we want to know what fraction of a circle we have, we're going to need to know the arc measure. So if we have something like 100 degrees for this arc, remember the arc measure is equal to the angle measure. Yeah, it looks like it might be closer to 90, but let's call it 100. Okay, just for good example's sake. So we've got 100. So if it's 100 degrees, what fraction of a circle do we have? Is it half a circle? No. Is it a quarter circle? Not quite, because 100 is not a quarter of 360. Oh, but what fraction is this? This is 100 3/60ths. So the length is 100 3/60ths times the circumference. And let's just pick a radius of, let's go back to that radius of 3. Why not? So this is 2 times pi times 3. So this is 100 3/60ths. Well, 100 3/60ths, let's simplify that. That's 1036 divided by 2. That's 5/18. 5/18 times 6 pi. Okay? We could cross cancel. I'm going to try that. 6 goes in there once. 6 goes in there 3 times. Cross canceling. Great way to do this. 5 times 1 is 5 pi over 3. Okay. So that's one way to do this. Okay. So we can say that is a fraction times 2 pi r times the circumference. Another way we can do this is like this. We can use proportions. This is 100 out of 360. That's the proportion we have. Okay, that is the ratio. We have 100 compared to 360 is the same as the arc length compared to the circumference, 2 pi r. Okay, so this is partial circle, full circle. This is partial length, full length. So we can do this as a proportion also. And with a proportion, we cross multiply. This is 100 times 6 pi, because that's 6 pi on the bottom. 600 pi equals 360. I can't read my own writing. A little sloppy on the stylus there. And then we can divide this by 360. And we can see that this is 63/60ths, and the 12 goes into both of that 5 times on the top and 3 times on the bottom. Okay, so we have two methods. We got the proportion method, and we have the fraction of method. All right, so two formulas here. We have a proportion. The arc length over 2 pi r equals the measure of the arc over the 360. So it's a partial measure over a full circle. Or we could say the arc length is equal to a fraction made by the arc measure over the total 360 times 2 pi r. So a fraction of a circle. And they're both useful in different cases. Let's try a few examples here. Find the indicated measure. So we want the arc length here. Okay. Well, the arc length here, I'm going to use the fraction method, is 60 out of 3/60ths. That's the fraction of the circle. Times 2 times pi times 8. the circumference. All right. Let's simplify that fraction before we try to multiply this. Let's get here is 16 pi. It's the circumference. And then this is 60 goes in 360. That's 1/6, right? All right. So this is 16 pi over 6, which is divided by 2 on top, divided by 2 on bottom, 8 pi over 3. That is approximately 8, right? 8 times pi divided by 3 is just 8. Well, it's not exactly 8 because pi is not 3 exactly. So it's a little bit more than 8, right? That's the idea. Okay. Here we have 40 degrees and a 4.19. This one's already a decimal, so usually when we have a decimal answer, we'll want, or decimal number to start with, we'll want a decimal answer in the end. So, circumference here is, well, let's try the proportion method here. This is 40 out of 360 equals the arc length, 4.19, over the whole circumference. So this is part to the whole, those are degrees, equals part to the whole. All right, so in this case, doing this proportion is a nice way to go. So if we cross multiply, we have 40c equals 4.19 times 360. And if we divide it by 40, we'll get our final answer here. And that's given us 37.71 there. And those are inches. So that's the idea. So when you're finding that circumference, probably using that proportion method will work best there, right? Find which method works best for you and use it. So here we want to find the measure of arc RS. Now careful here, we're not told much about that here. And measure, remember, is in degrees, so we're looking for so many degrees here. Well, we can find this degrees because we know this is 44. So we can say, if we call that x degrees, then x is to 360 as the circumference. So x is the partial degrees. So the partial length needs to go on top. The full length is the circumference, 2 times pi times 15.28. Okay. To solve this, we can cross multiply, or we can just multiply by 360 on both sides. That'll cancel that out. Okay, so we're going to have to compute this carefully here. So we'll get our calculator here. So we have 44 divided by, and you got to make sure that 2 and that pi and that 15.28 all go to the bottom. Oops. And then we got to multiply by 360. And there's our answer. Now, if you're doing this in a one-line calculator and it doesn't type it all out like this, you need to make sure that the 2 times pi times 15.28 is in parentheses. 14 divided by all of that, then times 360. So watch out for that. So this is 164.98, 160, rounds up to 165. Let's round that to 165 there, all right? So let's get this guy out of here. We know we're at 165 degrees. Now careful, that's this one, 165. So this RS, measure of RS, that's arc RS, is going to be 360 minus 165. 360 minus 160 is 200, minus 5 is 195 degrees. So a little twist there at the end. So that's arc length. So we have a part of a circle, okay? And remember, the big idea is that we have a fraction times the circumference to give us the arc length. So a couple quick applications before we're on our way. So we have curves of a track here. They're shown their 180-degree arcs. And a runner is going to run around this track. We know these straight distances here. Okay. Now careful with this drawing here. There's a little extra information. We're told that the radius of the arc for the runner is the red path. On the red path is 36.8. How far does this runner travel? Going once around the track. All right, this is the radius for the blue runner. We're talking the red runner here. Not the road runner, but the red runner. So, well, what do we have? We have half a circle here, right? So we have a half of a circle. Well, what would the circumference of this whole circle be here? Well, that would be 2 pi r. So 2 times pi times 36.8. Plus, we have 2 of these lengths here, right? 2 horizontals. So let's do 2 times 84.39. Plus, we have another half of a circle here. So this guy over here is going to be half of a circle. Hard to see that. All right, so half of a circle over on the right. Half of this full circle because it's a 180 degrees. So we got half of the same thing, 2 times pi times 36.8. And pretty clearly, if we have half a circle plus half a circle, that's just the whole circle. So we'll do a little algebra here and combine those things. So 2 times pi times 36.8, because 2 half circles make a whole circle, and plus 2 times 84.39. All right, we can go to our calculator with that. And it looks like we come out with a nice even 400.001. That's pretty good. So that is meters. Rounding the nearest tenth of a meter, as the directions said. We don't need, we do need that. But we don't need the zeros there. Okay, so we'll have 400.0 meters. All right. So here's a couple examples. I guess it's just this first one that's about a car tire. So when you have a car tire or a bike tire, all right, here's the front of our car. And as this car rolls, imagine there was a line here. And as this car rolls, this line will travel around and come back. So every time it rotates, every time the tire rotates, all of that tire will touch the ground, and that radius will rotate once. So for every circumference that it rotates, the car goes forward that distance. So when it rotates one time, the car will go forward that distance. So we have a car tire that has a diameter of 28 inches. The question is how many revolutions we'll need to take it to 500 feet. Okay? Now, first thing we might want to do is we want to convert this to feet. So 28 inches divided by 12 is going to give us, it's going to be feet. Okay? So let me erase that. If we take 28 divided by 12, we have feet. And simplifying that, 4 goes into both, that's 7/3 feet. So we'll use that as our radius. Nope, diameter. So 7/3 of a foot. So the question is, how many circumferences do we need to go 500 feet? So the circumference is 2 pi times 7/3, which is 14 pi over 3. Okay. And so 500 feet is how many rotations? So our revolutions is 500 divided by the circumference, 14 pi over 3. All right. So now Desmos lets us type that in there pretty nicely like this. 500 divided by 14 pi over 3. Or you could go figure out the decimal for 14 pi over 3 and divide that. And we get about 34.1. So 34.1 revolutions. So the tire traveled 34.1 revolutions. Okay. So how many circumferences determines how far it will go. So here's a problem you might want to pause the video and try just to make sure you're understanding. What about the runner that's going around the 44.02 track? How far does that runner have to go around the nearest tenth of a meter? All right, so you might try it there and pause it. See what you get for the 44.02. So if we use this idea that this runner going around the blue track is going a half a circle and another half a circle, well, that's a whole circle. That runner also has to run these straight portions here. Okay, so we got a full circle, taking a half and a half, and then plus the 84.39 doubled. All right, so that's going to give us, we have the length is going to be 2 times pi times that 44, because that's 2 half circles plus 2 of the straight portions. So we'll let our calculator do the work. 2 times 44.02. So the circumference plus the 2 straight strips gives us 445.4. 445.4. And if we compare that, so it's about 45 meters more than that other guy went, the red one. All right, so that's how we find the length. Remember, the key is that the length is a fraction of the circle. So if we want to find a partial length, we have the arc measure in degrees out of 360 times 2 pi r, the circumference. Or we could say the fraction, a over 360, a is the arc degrees, is going to be the arc length over the circumference, 2 pi r. And those are just two ways to get the same thing. All right, there you have it. So now we can find circumference and we can find the partial arc length as well. So keep working hard, do well.